Hello everyone. In this video, let's learn how a computer stores a negative number. We already learned that computers only understand zeros and ones. So if we have a positive number, let's say we have a plus 5 for example, so then the computer stores it as 0101 in its binary form. How about if we have a negative number, negative 5 for example, how does a computer store it? So there's no such a thing such as a negative sign. The computer doesn't understand negative. So the computer stores it in what we call 2's complement. The question is, how can we find the 2's complement of any negative number? So we can follow these simple steps. Step 1, we find the magnitude of the negative number to get it in positive. So step 2, we find the binary number of the decimal number in step 1. Step 3, we flip all the bits of the binary number we obtain in step 2. So when I say flip bits, that means all the zeros become ones, and then all the ones become zeros. And then last step, we add 1 to the number in step 3. So let's do a quick example. Let's see how a computer stores negative 5, for example. So step 1, we need to find the magnitude of negative 5, and this will be plus 5. In step 2, we need to find the binary format of number 5. We already learned this in a previous video, but let's do it really quick. So let me store the remainder here. 5 divided by 2 is 2 with remainder 1. 2 divided by 2 is 1 with remainder 0. So now we can take these bits and this will be our number 5. So 5 will be equal to 1, 0, 1. We can add 0 to the left because it doesn't change the number. So next step, we need to flip all the bits of this number here. So 0, 1, 0, 1 becomes 1, 0, 1, 0. And then the last step, we need to add 1. So plus 1. And we add zeros to the left of the 1. So now let's add these. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. And 1 plus 0 is 1. So this is how a computer stores a negative number. Negative 5 is equivalent to 1011. Now let's verify. How can we verify our work is correct? How can we verify 1011 is equal to negative 5? Let's do it. So we already learned that we have two different types of binary number system, signed and unsigned. Signed numbers could be positive or negative, and they're determined by the most significant bit, the leftmost bit. If this is 1, then the number is negative. If this is 0, then the number is positive. So looking at 1011, we reserve the most significant bit 1 for the sign. Since this is 1, so this number we know it's negative number. Now let's find the next step. We take 1011 and we want to find the decimal number of 1011. So the first step, we flip all bits. So 1011 becomes 0100. The next step, we need to add 1 to this number here. So adding 1, 0, 0, 0, and we're adding these two numbers. 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, and 0 plus 0 is 0. Now let's convert this one to a decimal. So this one we multiply it by 2 to the power 0. We don't have to worry about the zeros because they're zeros. So this one here we multiply it by 2 to the power 2. And this will give us 2 to the power 2 times 1 is 4, plus 2 to the power 0 times 1 is 1. So this is equal to 5. And we know that it's negative number, so this will be equal to negative 5. So that verify 1011 is equal to negative 5. So let's take another example. Let's see how a computer stores negative 28. So we want to find its 2's complement. Step 1, we find the magnitude of negative 28, which is equal to plus 28. Step 2, we need to find the binary equivalent to 28. So let's do it. 28, I'm going to store the remainder here. So 28 divided by 2 is 14 with the remainder 0. 14 divided by 2 is 7 with the remainder 0. 7 divided by 2 is 3 with the remainder 1. 3 divided by 2 is 1 with the remainder 1. So now taking all of these bits, we can write 28 in binary number system. So 28 will be equal to 1, 1, 1, 0, 0. So this is 5 bits number. To make it 8 bits, we can add 3 zeros to the left. 1, 2, 3. So step 3, we need to flip all the bits of this number. So this becomes 1, 1, 1, 0, 0, 0, 1, 1. And step 4, we need to add 1 to this number. So plus 1. We saw also in the previous videos that 1 plus 1 in binary addition is 0 with carry 1. 1 plus 1 plus 0 is also 0 with carry 1. 1 plus 0 plus 0 is 1. 0 plus 0 is 0. Same here. And then 1 plus 0 is 1. So 1, 1, 1. So this number here is the 2's complement of negative 28, which is how the computer stores negative 28. Let's also verify that this is correct. So in other words, we want to find the equivalent number of this binary number in decimal. So since the most significant bit is 1, so we know that this number is negative because this bit is reserved for the sign. The next step, we need to flip all the bits in this number. So this becomes 0, 0, 0, 1, 1, 0, 1, 1. Then we add 1 to it. Zeros all the way. So this will be 1 plus 1 is 0 with carry 1. 1 plus 1 plus 0 is 0 with carry 1. We have 1, 1, 1, 0, 0, 0. So now let's find the decimal number of this last number here. So this, we multiply this by 2 to the power 0, but since it's 0, we don't have to worry about it. So all we have to worry about these 3 bits here. So we multiply this one by 2 to the power 2 to the power 3, 2 times to the power 4. So this will be 1 times 2 to the power 4 is 16, plus 1 times 2 to the power 3 is 8, plus 1 times 2 to the power 2 is 4. So adding these numbers will be equal to 28, and we know that it's a negative number from the most significant bit because it's 1, so this number will be equal to negative 28. So this is how we can verify our work. So in this video, we learned how a computer stores a negative number in its memory. Hope this was helpful. Thanks for watching.